Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with an oblique square prism which is having edge of the base is equal to 30 millimeter and the axis height it is equal to 55 millimeter. Now this square prism, it has got its axis inclined at an angle of 45 degree to the horizontal plane while it is resting on one of the edge of its base onto the horizontal plane. So let us first of all evaluate the orientation of the square prism with respect to the horizontal plane. So if we are going to locate the prism resting onto the horizontal plane into this orientation, then if we are going to incline the prism either this way or we are going to incline the axis of the prism this way, then it will be resting on one of the corners of its base. It will not be resting upon one of the edges of its base onto the horizontal plane. So this orientation of the square prism onto the horizontal plane is incorrect. So if we are going to locate the prism onto the horizontal plane into this orientation, then when we are going to incline the prism either this way or this way, so we are going to get prism resting onto the horizontal plane on one of its edges. This can be edge CD or it can be the edge AB over here. So this way the inclination of this particular square prism with respect to HP will mean that it will be resting on one of its edges onto the horizontal plane. So this is the appropriate orientation or location of the square prism with respect to the two reference planes over there. Now in the second iteration we have been provided with the information that the edge onto which this prism is resting onto the ground, this is further inclined at an angle of 30 degree with respect to the vertical plane. That is, this edge will be further inclined at an angle of 30 degree with respect to the vertical plane. So this is the oblique solid that we have with us. So we are required to draw the orthographic projections of this oblique square prism. So to begin with, we have to draw the top view projections of the square prism, and the top view projection will be a square which will be drawn onto the horizontal plane, and these projections will be drawn below the XY reference line. And when we look at this prism from the front side, so on the vertical plane, so we are going to get the rectangular projections of the square prism onto the vertical plane in the front view projection. So let us proceed with the construction of the orthographic projections of the square prism when the prism is resting onto the ground on its square base over there. So as we have discussed, the top view projection of the square prism will be a square, and we are going to have the edge of the square, it is equal to 30 millimeter. So we are going to draw the square top view projections below the XY reference line as top view projections over here. So the bottom face, it is labeled as A, B, C, D. So here we have got the top view projections corresponding to the base of the square prism as A, B, C and D over here. And the top face of the square prism, it is marked as 1, 2, 3 and 4. So now the projections of the top face of the square prism we have marked as 1, 2, 3 and 4 over here. Now we have to evaluate the axis of this prism. So in order to evaluate the axis, now these two diagonals we have joined. That is 2 and 4 we have joined, 1 and 3 we have joined over here. So wherever the intersection of these two diagonals is occurring, so here we get the points O and O1. So O point will be the axis point at the top, while O1 point, it is the axis point which is available at the base of this particular square prism. So we know that this is the axis of the prism. So we have marked this axis over here as a chain line, and now we know that the height of this particular square prism, it happens to be 55 millimeter. So now once we mark this height of the prism as 55 millimeter, now we are going to obtain the front view projections of the square prism appearing as a rectangular projections onto the vertical plane. So the front view projections will be B dash, A dash and C dash and D dash corresponding to the base. So we can see B and A, they will be projected as B dash and A dash onto the XY reference line. Similarly, points C and D, they will be projected as C dash and D dash onto the XY reference line. Now these projections, they are corresponding to the points A, B, C, D of the base. Similarly, corresponding to the top face, we are going to get projections of 2 and 1. They will be projected as 2 dash and 1 dash onto the top face. Similarly, projections corresponding to the points 3 and 4, they will be projected as 3 dash and 4 dash onto the top face of the square prism. And now here we have point O dash corresponding to the top face of the square prism, and point O1 dash we have drawn corresponding to the axis point at the base of the square prism. Now, having obtained the orthographic projections of the square prism which is resting onto the ground on its base, now we know that the axis of the square prism happens to be inclined at an angle of 45 degree with respect to the horizontal plane. Now we have to draw the axis to be inclined at 45 degree with respect to the horizontal plane. So if the axis of the prism is inclined at an angle of 45 degree, then the base of the prism will be inclined at an angle of 90 degree minus the axis inclination. That is again 90 degree minus 45 degree means 45 degree. Now this rectangular front view projection which we have already obtained in the previous view, this projection we have to reorient or transform or rotate at an angle of 45 degree with respect to the horizontal plane. So now we have to rearrange or reorient this rectangular projection in such a way that the base of this particular rectangular projection will be inclined at an angle of 45 degree with respect to HP. So axis is also inclined at an angle of 45 degree to HP, while the base is also inclined at an angle of 45 degree to the horizontal plane. Now once we draw this base at an angle of 45 degree, now we have to mark this point over here in such a way that this distance C dash, D dash and O1 dash, so this distance should be marked at an angle of 45 degree with respect to the horizontal plane, and this point will give us the location of the axis point over here. Similarly, the distance of O1 dash and B dash A dash should also be equal to this distance, which will be equal to 15 millimeter. So this distance is also 15 millimeter. This distance is also 15 millimeter. So this distance over here will be drawn as 15 millimeter, and again this distance, that is O1 dash and B dash A dash distance, will also be marked as 15 millimeter. So this is 15, this is also 15, and now we know that the height of the axis, it happens to be 55 millimeter. That this prism is having the height is equal to 55 millimeter. So from point 1, point 2 and point 3. So we are going to draw perpendicular distance which is going to measure 55 millimeter each over here. So once we draw these three distances equal to 55 millimeter, so we will be able to transform or rotate the rectangular projections which we had obtained earlier at an angle of 45 degree with respect to the horizontal plane. So now we are able to obtain point C1 dash, D1 dash resting onto the ground, B1 dash, A1 dash, it is lying over here, and similarly corresponding to the top face of the square prism, we have been able to identify the points 2, 1 dash, 1 1 dash and 3 1 dash and 4 1 dash, and corresponding to the axis we have got points O1 dash and O11 dash located over here. Now, having obtained the front view projections of the square prism, when the axis of the prism has been inclined at an angle of 45 degree with respect to the horizontal plane, and the prism is resting onto the ground on one of its edges over there, which happens to be the edge CD. So here we can check C1 dash D1 dash is the edge which is resting onto the ground over here. So now, having obtained the front view projections of this inclined square prism, now we are required to draw the corresponding top view projections of this inclined prism over here. So how the corresponding top view projections they will be obtained? Now, how many points do we have? 4 points corresponding to the base, 4 points corresponding to the top face, plus 2 axis point. So we are going to have 10 points in the front view projections corresponding to the square prism. So from all these 10 points, that is 5 points corresponding to the base, 5 points corresponding to the top face. Now from all these 10 points, we are going to look at the solid from the top, and now we have to draw the projector lines from all of these 10 points in such a way that these vertical projectors, they need to be extended into the top view projection area, and then we have to draw the horizontal projector lines from the previous plan projection view 10 points over there. So once we draw the horizontal projectors through these 10 points, that is 10 points corresponding to the previous plan projection view, then we will be evaluating the points of intersection of the corresponding points into the plan projection view over here. So wherever the intersection of the vertical projector from a particular point intersects with the horizontal projector from the same point corresponding to the plan view, so there we are going to obtain the corresponding plan projection points over here. So we can see over here there are 4 points lying over here. So once we draw first horizontal line, so onto this horizontal line 4 points corresponding to the plan projection view they will be available. Similarly, here also we have got 4 points lying into the plan projection view which we have already drawn. Now from here, once we draw the horizontal projector line, now onto this horizontal projector line we are going to get 4 points into the plan projection view. Let us evaluate those 8 points over here. So we can see we have marked the 4 points corresponding to the base of the square prism. So here we have the base of the square prism. Now let us check what are these 4 points. So we have drawn a vertical projector from the point A1 dash of the elevation view, and once we draw this vertical projector from A1 dash, now this vertical projector must intersect with the horizontal projector drawn through the point A, which is available with us from the previous plan projection view. So once we draw horizontal projector through A, vertical projector through A1 dash, the intersection point provides us with the location of the point A1. Similarly, the vertical projector through the point B1 dash and the horizontal projector through the point B, wherever these two projectors they intersect, we obtain the point B1 in the plan projection view. Similarly, we have vertical projector through point C1 dash, and wherever this vertical projector through C1 dash it intersects with the horizontal projector drawn through the point C, we obtain the point C1 over here. And finally, corresponding to the base, we have drawn a vertical projector line drawn through the point D1 dash, and wherever this vertical projector line drawn through D1 dash it intersects with the horizontal projector line drawn through the point D of the previous plan projection view, we have obtained the point D1 over here. Similarly, corresponding to the top face, again 4 points we will be able to obtain over here. So let us see which are these 4 points. Here we have drawn a vertical projector through 1 1 dash, and here we have drawn horizontal projector through the point 1 over here. So the intersection of these two projectors provides us with the location of the point 1, 1. Similarly, here we have the point 2, 1 dash. So from point 2, 1 dash, we have drawn a vertical projector line. From the point 2 of the previous plan projection view, we have drawn a horizontal projector line. Wherever these two projector lines, they are going to intersect, we obtain the point 2, 1 over here. Similarly, the vertical projector through 3, 1 dash and horizontal projector through point 3, wherever they intersect, we obtain the point 3, 1, and vertical projector through 4, 1 dash and the horizontal projector through point 4. So wherever they have intersected, we have been able to obtain the point 4, 1 over here. Now these are the two access points. Now corresponding to the access point, once again, we have drawn a horizontal line, and wherever this horizontal line drawn through O and O1, it intersects with the vertical projectors drawn through O11 dash and O1 dash over here. So here we will be obtaining the point O1. Here we will be obtaining the point O11. Now we know that which are the lines which we need to join. We need to join the base points A, B, C, D, A. We need to join the top face points 1, 2, 3, 4, 1. We also need to join A1, B2, C3 and D4. So now you can see here we have joined all of these edges over here, but C1, D1 we have joined as a dotted line or a hidden line. So why this hidden line has been drawn? Now we can see that as we are going to look at the square prism from the top, C1 dash, D1 dash happens to be the point which are lying farthest away from the observer and closest to the plane. So anything joining C1 and D1 in the top view should be drawn as a dotted line, unless those edges, they are going to be lying onto the boundary of the solid. So we can see C1, D1, this edge is lying at the bottom. So this we have drawn as a dotted line or a hidden line. Whereas we have joined A1, D1 as dark because it is falling onto the boundary of the solid. Similarly, C1, B1 also we have joined dark because again it is lying onto the boundary of the solid. Similarly, D1 and 4,1 also we have joined as dark because again it is lying onto the boundary of the solid. And finally, C1, 3,1 also we have joined as dark because again it is falling onto the boundary of the solid. So therefore, the top view projections of this inclined square prism, which is having its axis inclined at an angle of 45 degree with respect to the horizontal plane, they have been obtained. Now, once we have obtained the top view projections as well as the front view projections of this inclined square prism, we observe that the edge onto which the prism is resting, which is this edge. This edge happens to be C1 dash, D1 dash in the front view and C1, D1 in the top view projection over here. We can see we have tilted the prism in this orientation. Now the prism is resting onto the ground on one of its edges, that is edge CD over here. Now this is the edge CD onto which the prism happens to be lying onto the horizontal plane. And in the top view projections, we are still able to obtain the true length projections of this edge C1, D1 in the top view projection over here. Now, in the second iteration, we have been provided with the information that edge of its base on which the prism is resting, it is further inclined at an angle of 30 degree with respect to the vertical plane. Now, these top view projections, they have to be rotated in such a way. Now the focus will be on this edge C1, D1. Now this edge C1, D1 is further inclined at an angle of 30 degree with respect to the vertical plane. Now you can check, we have marked this angle as angle phi. Why we have marked this angle as angle phi? Because onto this orientation line, the true length of the edge onto which the prism is resting onto the ground has to be located, and we have obtained the true length of this edge onto the horizontal plane. So this projection C1 D1 happens to be true length. So since C2 D2 will be located over here alongside this projection line which is inclined at an angle of 30 degree, so true length of the edge onto which the prism is resting onto the ground is located at 30 degree. That is why the angle of inclination has been marked as phi is equal to 30 degree with respect to the vertical plane. So now using the method of rectilinear projections, we have to transfer the plan projection view which we had earlier obtained at an angle of 30 degree in such a way that points C1 and D1, they will be obtained as C2 and D2 onto this orientation line which has been drawn at an angle of 30 degree. So now we know the size of this rectangle. We can check. We know the size of the rectangle. We know this edge over here, it is going to lie as C2 D2 over here. So once we know this edge will be C2 D2, we know this distance between B1 and C1. So once we measure this distance B1 C1, we'll be able to mark this edge and this edge, and then we join A1 B1 over here. So A2 B2 will be located over here. Similarly, we also know the distance between C1 and 3,1. So this is same distance C1 3,1 and D1 4,1 over here. So once we mark these two distances, so this rectangular projection, they will be transferred over here. And finally, distance between C1 and 2,1 and distance between D1 and 1,1 also we know. So D1 and 1,1 distance we will be marking, and distance between C1 and 2,1 we are going to mark. So this will be C2, this will be 2,2, this will be D2, this will be 1,2. So this way, all the 8 points corresponding to the base as well as the top face of the square prism from the previous plan projection view, they have been appropriately transformed or rotated into the new orientation over here. That is, we have been able to obtain the top view projections of this oblique solid when the axis is inclined at an angle of 45 degree to the horizontal plane, and the edge of the base onto which the prism is resting, that is inclined at an angle of 30 degree with respect to the vertical plane. So these are the top view orthographic projections of the square prism which is inclined with respect to HP as well as with respect to VP. Now we also need to mark the location of the points O1 and O11. So we know that this total distance, this happens to be 30 millimeter. Axis will be located at a distance of 15 millimeter. So 15 millimeter from this point, we mark a point. 15 millimeter from this point, we mark a point. And then we will be drawing a construction line over here. And then this distance we know, this distance we also know. So this distance and this distance we know. So measure this distance, you get point O21. You measure this distance, you get the point O2. So all the 10 points of the previous plan projection view, they have been appropriately transformed or rotated into the orthographic top view projections of this oblique solid. Now we have to evaluate the corresponding front view projections of this oblique solid, which is inclined to HP as well as inclined to the vertical plane. So from these 4 points, from these 4 points and from these 2 points, so total of 10 points, they are available with us in the top view projections of this oblique solid. Now from these 10 points, now you can see we have drawn the vertical projector lines into the elevation view, and we need to find out the corresponding points of intersection between the vertical projector lines which we have drawn through all the plan projection points of the current view and the horizontal projector lines we are going to draw, which will give us the corresponding points of intersection into the elevation projection view over here. Now you can see that here we have points C1 dash and D1 dash located onto the horizontal plane. That is, this is the edge onto which the prism is resting onto the ground. So through C1 dash and D1 dash, we have drawn the horizontal projector line. You can check. This is the horizontal projector line that is alongside XY reference line. So let us see, where does this construction line or the projection line, it intersects with the vertical projector lines which are drawn through the points C2 and D2 from the top view projection over here. So we can check. If we draw a vertical projector line through C2, it will be intersecting with this horizontal projector line over here. So this will provide us with the location of the point C2 dash. Similarly, here we have the point D2 located over here. From D2, if we draw a vertical projector line, from D1 dash, we have drawn a horizontal projector line. So the intersection of these two projection lines will locate the point D2 dash over here. Next, we have got another 2 points corresponding to the base B1 dash and A1 dash. So now we have drawn a horizontal projector line through B1 dash and A1 dash. So wherever this horizontal construction line or a projection line, it intersects with the vertical projector lines drawn through the points A2 and B2 of the plan projection view, we will be obtaining the points A2 dash and B2 dash. So here we can see vertical projector through A2 and horizontal projector through A1 dash. They intersect over here. We obtain the point A2 dash. The vertical projector through B2 and the horizontal projector through B1 dash, they have intersected over here. So this has provided us with the location of B2 dash. So all the 4 points of the base A2 dash, B2 dash, C2 dash and D2 dash, they have been located. Next, we have got 4 points corresponding to the top face of the square prism. So here we have got points 3,1 dash and 4,1 dash from the previous elevation projection view. So from 3,1 dash and 4,1 dash, we have drawn a horizontal projector line. Now we are going to draw the vertical projector lines through the points 3,2 and 4,2. So here we can see this is point 3,2. We draw a vertical projector line through 3,2. It intersects with this horizontal construction line drawn through the point 3,1 dash. So here we obtain the point 3,2 dash over here. Similarly, here we have the point 4,2. So from 4,2 we have drawn a vertical projector line. It intersects with the horizontal projector line drawn through 4,1 dash. So here we obtain the point 4,2 dash over here. And next we have got points 2,1 dash and 1,1 dash. If we draw a horizontal projector line through 2,1 dash and 1,1 dash, now let us see. Here we have got point 1,2. So from 1,2, if we draw a vertical projector line, it intersects with this horizontal projector line drawn through 1,1 dash. So here we obtain the point 1,2 dash over here. Similarly, here we have the point 2,2 from the plan projection view. So if we draw a vertical projector line through point 2,2, now this vertical projector line intersects with this horizontal line drawn through 2,1 dash. So this intersection of these two projection lines provides us with the location of the point 2,2 dash over here. Now finally the axis points we need to draw. So here we have the axis point O21. So we have drawn a vertical projector line through O21 and a horizontal projector line drawn through O11 dash. So wherever these two intersect, we have obtained the point axis point corresponding to the base. Similarly, here we have the axis point corresponding to the top face, that is O2. If we draw a vertical projector line through O2 and the horizontal projector line, if we draw through O1 dash, again axis point corresponding to the top face we have been able to obtain. So all the 10 points we have been able to obtain in the elevation projection view corresponding to the oblique solid. Now which are the edges which we need to join? We need to join the top face 1,2 dash, 2,2 dash, 3,2 dash and 4,2 dash and 1,2 dash. Similarly, corresponding to the base, we need to join the base edges A2 dash, B2 dash, C2 dash, D2 dash and A2 dash. And besides this, we need to join 1,2 dash, A2 dash, 2,2 dash, B2 dash, 3,2 dash, C2 dash and 4,2 dash and D2 dash. But which one of these edges we have to join using object line, which one of these edges we need to join using the hidden line. Now since we are going to look at the solid from this side, now we can see as we are going to look at the solid from this side, A2 is the point which is farthest away from the observer. So anything joining A2 dash should be drawn as dotted line unless those edges they constitute the boundary of the solid. So let us join all the edges over there. You can check 1 2 dash, 2 2 dash, 3 2 dash, 4 2 dash, 1 2 dash we have joined. Similarly, A2 dash, B2 dash, C2 dash, D2 dash, A2 dash we have joined. Again 1 2 dash, A2 dash, 2 2 dash, B2 dash, 3 2 dash, C2 dash and 4 2 dash, D2 dash we have joined. So all these edges we have joined, but only 3 edges we have joined as dotted one or hidden lines. Why? Because A2 it is the farthest point from the observer. So all the 3 edges, that is A2 dash, B2 dash, A2 dash, D2 dash and A2 dash, 1 2 dash, since they are lying on the back side, they are not constituting the boundary of the solid. So these 3 edges we have drawn as hidden lines, and rest all of the edges we have marked as object lines or the solid lines over here. So this way we have been able to evaluate the front view projections as well as the top view projections of an oblique solid in which the axis is inclined at an angle of 45 degree to the horizontal plane, and the edge onto which the solid is resting onto the ground, this is further inclined at an angle of 30 degree with respect to the vertical plane. So now we also need to join these axis points. Now you can see we have marked these 2 axis points. So we have joined the axis points over here. So with this we complete the discussion regarding the construction of the orthographic projections of an oblique square prism which happens to be inclined with respect to horizontal plane as well as with respect to the vertical plane. So this is all for today. So I hope that through this discussion you would have learnt about the procedure for construction of orthographic projections of the oblique square prism. So we will be continuing with further discussion regarding few more illustrative cases of projections of the oblique solids in the coming lecture. So thank you very much. Thanks a lot.